Hello and welcome to the Graphing Trig Day 4 video. If it sounds a little echoey, it's because I'm not recording this at my place of residence. I'm recording this at school and the classroom is much bigger than my living room and so it tends to echo. So I'm sorry about that sound quality. But in this video, we are going to just be going over two problems from the Go Formative that's just, let's practice our transformative graphing with trig functions. So let's start with problem number 1. Now problem number 1 is y is equal to 3 times sine of 1/2 of x minus 60 degrees. Or if we want to think about this in terms of our different colors, this is going to be 3 times sine of 1/2 of x minus 60 degrees plus 0. So when we go through and we find all of our features, we can see that our amplitude is 3, so it's been stretched out 3 tall. Our frequency is 1/2, so it means we can only see half of one full cycle in an interval of, I'm going to say 360 degrees, since we have degrees in our problem. Next is going to be our period. So remember, our period is either 2 pi or 360, so in this case 360 degrees, divided by your frequency, or in this case divided by 1/2. Well, that's the same as 360 times 2, or times 2 over 1, and that's going to give us 720 degrees. So we have a period, or one full cycle of 720 degrees, so it got really stretched out. Next we have our phase shift of 60 degrees. So I flipped the sign, so it's not minus 60 degrees, it's 60 degrees, or it's moving to the right. It's moving in that positive direction. And then very lastly, our midline, I don't have one, so we're just gonna say 0. So when we set up our graph, it's gonna be up to us to determine, okay, what is our scaling, how should we set this up? Well, I see that our amplitude is 3, so I know our y-axis is going to have to be semi-tall. And then I also see our shift is 60 degrees. Now, normally when I'm dealing with degrees, I do every block is 45 degrees, or every 2 blocks is 90. But I don't know if that'll work for us, because 60 doesn't really fall on there. So instead of doing that, I'm going to set my scale by 30 degrees for each square. So you don't have to have the same scaling every single time. Hopefully this will leave me enough space. Let's call this 4 to be our axes right there. Hopefully if this is enough space. If not, I will just have to re-record this. -4. Okay, so this should give us enough space for our y-axis. Now for my x-axis, like I said, I'm going to do 30 degrees, which would make this 60, which would make this one 90. Now, you don't have to go through and mark up every single axis. I can just see here that 3 blocks is 90 degrees. So I can go another 1, 2, 3 and see that we get to 180, another 1, 2, 3, see that we get to 270, and another 1, 2, 3, and we get to 360. Oh, and this is enough space. Perfect. I love it. So just make sure you do the other side as well. So it'll be -90 degrees, 1, 2, 3, -180 degrees, 1, 2, 3, -270 degrees, and 1, 2, 3, -360. So make sure you're going from -360 to +360 in your axes. So when we start graphing, let's put in just some information to help us out. So let's see, I know that my midline is at 0, so I'm going to dash in my midline here. And then I know my amplitude is 3 spaces up from that, so we'll put a dashed line at 3, and then we'll put 3 below. Whoops, I just clicked something on my pens. There we are. So 3 below. So I know that all of my points should either be on this red dashed line or this yellow dashed line. If I have points outside of that, that's not good. So next, I'm going to put in my phase shift. So because this is a sine function, I know it's going to be on my midline, and I see it's at 60 degrees. So I'm going to put a point at 60 degrees on my midline saying, hey, that's my shift, because it used to be on the y-axis. So now I'm like, okay, what do I do for the rest of my points? I'm going to find my graphing interval. First, I'm going to erase this just a little bit. Is it not going to let me? There we go. Okay. So for my graphing interval, it tells me how far apart I should put all my points, and that's going to be your period divided by 4. So in this case, if we do 720 divided by 4, it's divided by 4 every time, we're going to get 180 degrees. So we're going to have a point every 180 degrees, or if we take a look at this specific scaling, that's going to be 6 squares. So I want you to check for what that is for whatever you're scaling. If you decided to scale it by every 15 or every 20 or something like that, you're going to have more squares, but it should still be 180 degrees later. So because this is a positive sine function, I know that when I start at my point and move to the right, I have to move up. So I'm going to go over 1, 2, 3, 4, 5, 6 squares and move up. So I'm going to have a point here. And then the next time when I move over 6 squares, 1, 2, 3, 4, 5, 6, it kind of goes off my graph, so you can just leave it here for now. Now, when I go to the left, I'm going to move downward. So it'll be 1, 2, 3, 4, 5, 6 spaces, and then down. And then from here, I'll move 1, 2, 3, 4, 5, 6 spaces, and then back up to my midline. So this is what we see. It's really not a lot of our graph because it got stretched out a whole bunch. So I'm going to just graph this to the best of my ability with a curve. So make sure to stick an arrow at the end. Same here. I'm going to come up here. I'm not going to stop it here. I'm going to continue down this way. I'm just going to put an arrow to show that that continues onward. But this is our graph, and I can tell that we did this correctly because our frequency is 1/2, and we can see that we went through 1/2 of a cycle, so just like the bottom part of a cycle, in an interval of 360. So we only went through a part of that, and that's okay. But this is our graph. We're done with that problem. Let's try just one more. So let's take a look at problem number 4. Oops, sorry, I forgot this was still the highlighter. Let's see, problem number 4 is y is equal to 5 cosine of 2/3 times x minus, 180 degrees. Or if we were to, again, think about this in our color coding, it's going to be 5 times cosine of 2/3 times x minus 180 degrees plus 0. So if we were to go through and find all of our features, we can say that our amplitude is 5, so this one got stretched out a whole lot. Our frequency is 2/3. Now that may be a little bit harder to see when we actually do the graph, but our frequency is 2/3. We can see 2/3 of one full cycle in an interval of 360 degrees. And then our period is going to be 360 divided by our frequency, or in this case 2/3. So it's going to become 360 times 3/2 is a way you can think about that. And we get 540 degrees. So our period now is 540 degrees to complete one full cycle. Next we have our phase shift, which we're going to flip that sign and make it become a positive 180 degrees. Just remember that moves to the right. And then lastly, our midline is at 0. I don't know why all the examples have a midline of 0, but just keep in mind that if your midline is something other than 0, it just moves the graph up or down. It changes that midline. So now when we take a look at our scaling, I see that my phase shift here is 180 degrees. We can do it by 30 like we did last time. I'm going to do it by 45 just to kind of save some space. And I'm also going to want to make sure that I make this really tall because I know it has to go up pretty high. So let's say I'm going to make this 6, 4, 2, I'll put my axis right here. Perfect, and then we'll have -2, -4, -6. So just giving myself some space. And then, like I said, you can scale your x-axis however you want. I'm just going to do it where every block is 45 degrees. So that would be 45, that would be 90. 2 blocks later will be 180. 2 blocks later will be 270. And 2 blocks later will be 360. So you can scale it like this. You can scale it by 30s, just however you want. And I'm going to do the same thing on my left. Maybe should have made the scaling of the blocks a little bit bigger, but that's okay. So we have our scaling. Now let's put in where our midline and our amplitude will go. So our midline is at 0, and our amplitude is 5 up from that. So we'll do a dash red line at 5. It'll be 5 down from that. So we'll do a dash red line at -5. So I know that all of our points should be on these dashed lines. I've dealt with my midline and amplitude. So let's look at our phase shift. Now I know that it's going to be at 180 degrees. And because this is a cosine, a positive cosine function, I know we're going to start up here at the top. So I'm going to start up here at the top because that is a cosine function. But now I'm like, well, how far apart do my points need to be? So let's find that graphing interval. So for the graphing interval, you take the period and divide it by 4. So in this case, that'll be 540 degrees divided by 4, or 135 degrees. So we're going to place something every 135 degrees, or for us, that means 3 squares. If you scaled yours differently, that might mean a little bit more, but for right now, that is 3 squares. There we go. So let's see if I'm at here at the top. The only place I can move is down. So I'm going to move over 1, 2, 3 squares. 2, 3. I'll move down, and that gets us pretty close to the edge. So I'm actually going to go to the left now and count to the left 1, 2, 3, and down to my midline. I'm going to count over another 1, 2, 3, and then all the way down. And then I'm going to continue that pattern. So 1, 2, 3, and then I have to go back up to my midline, and then count over 1, 2, 3, and all the way back up here. So we have a few more points than we did in our last graph. Just make sure, I always kind of like to do like parabolas. So I do like a half here, do a half here, I do partial here. Now don't just leave this, make sure to stick some arrows at the end of your graphs so we kind of know what's going on there and we know that it is continuous. So it's a little hard to see the frequency here because it's hard to see 2/3 of a circle. But I know that we have done this correctly because we have one full period from -360 to 180 degrees. That's how long it takes to repeat itself, and that is an interval of 540 degrees. So these are just some examples of what we're going to be working on, identifying those features, graphing it to the best of our ability. Let me know if you have any questions. I look forward to seeing you in class.